Today you're going to learn about midsegments of a triangle. There are 5 things that you need to know about this triangle or any triangle that has a midsegment. First of all, we know that segment DE is a midsegment because the point D and point E are midpoints of segment AC and BC respectively. So what we need to make sure we understand is that the mid segment, which is that yellow segment, is connected or formed by the midpoints of 2 sides of the triangle. We also know that segment DE, which is the mid segment, and segment AB are parallel to each other. And so in order for us to find the length of segment DE, which is the mid segment, basically all you do is take the base, which is segment AB, and take half of it. Or we can say take the length of segment AB and divide by 2. Triangles have 3 mid segments. The first mid segment is going to be segment MN. In order for segment MN to be the mid-segment, segment DM has to be congruent to segment MC, and segment DN has to be congruent to segment NE. This mid-segment is parallel to the base, which is segment CE. So that is the first mid-segment. The next mid-segment is segment PN. In order for that to be a mid-segment, segment EN has to be congruent to segment ND, and segment EP has to be congruent to segment PC. The base that this mid-segment is parallel to is segment CD. So the next mid-segment is segment PN. The third mid-segment is segment MP. Segment MP can be a mid-segment so that CM is the same as MD and CP is equal to PE. The base that it's parallel to is segment DE. So therefore, all triangles have 3 mid-segments. And in order for that to happen, the sides have to be split in half by the midpoints and they're joined to those points. So if you notice in the interior of this triangle, there is a triangle and those mid-segments form that triangle. Now we want to calculate the distance between A and B. A and B is going to be the mid-segment, and in order for that to happen, BP and BR has to be congruent and PA and AQ has to be congruent. Remember that the formula for a mid-segment is taking the length of segment QR, which is the base that is parallel to, and dividing that by 2. So the length of segment AB is equal to 25 divided by 2, which is 12.5. Now we have decimals, and we still want to find one of those segments. But this time, we want to find the base. The mid-segment is 12.7. So we have to reverse it. So if we're looking for the length of segment CB, it is 2 times the mid-segment DE. So we're going to take 2 and multiply by 12.7. and we'll end up with 25.4. So this base that's parallel to the mid-segment DE is 25.4 units long. Here we're given the base. We're looking for the mid-segment, EF. So if we're given the base, we take the length of that base divide by 2, and you'll end up with the mid-segment. In this case, we get 15.5. In this one, we want to look for the length of segment BE, which is part of the entire base. The mid-segment of this triangle is 22. So if we take 22 and multiply by 2, we'll get 44. The entire base is 44 units long. Therefore, if E is the midpoint, these two segments are congruent. If I divide 44 by 2, we'll end up with 22, which is this segment and also this segment. Notice that the mid-segment is those lengths. So we don't have to go through this process anymore. We just have to remember that the mid-segment is half of the base. You divide by 2. Now here we want to look for the measure of angle ADE. If segment DE and segment CB are parallel to each other, then these two angles are congruent, which are corresponding angles. So the measure of angle ADE is 55 degrees. Now here we know that point D is the midpoint of segment AC. Point E is the midpoint of segment EAB, and point F is the midpoint of segment CB. DE is a mid-segment. It's 15 units long, which means that the base, which is BC, is twice that, and 2 times 15, this base would end up to be 30 units long. Segment EF is 9. The base of that one is A to C. So 2 times 9, this segment will be 18. And then segment DF is 13 units long. The base is AB. So it's 2 times 13, which is 26 units long. So if we're looking for the perimeter of this triangle ABC, we'll add those lengths together, and then that will be my perimeter. So you'll end up with 30 plus 26 is 56. If I add 56 to 18, I end up with 74 units long. So the perimeter of this triangle is 74. Now that's the long route. But there's another way that I can do this particular problem. So if you notice on the inside of that particular triangle, the bigger triangle, we have the length of segment DE is 15, segment EF is 9, and segment DF is 13. Well, if I take those three numbers and add them together, I'll end up with 28 plus 9, which is 37. And if I wanted to find the perimeter of the bigger triangle, which is similar to that one, I would just take 37 and multiply by 2, and I'll still get 74. So either way, you will find the perimeter of that triangle.